Introduction. Voltage control oscillator, or known as VCO, is a relaxation oscillator whose frequency can be changed by a variable direct current voltage. Output frequency is directly related to the voltage at its input. The oscillation frequency varies from few hertz to hundreds of gigahertz. The waveform of VCO can be sinusoidal or non-sinusoidal. It works by transferring energy back and forth from one form to another. One way to do this is with LC circuit, where energy moves between the inductor L and the capacitor C. The capacitor stores energy in the form of electric fields between its plates and discharges through the inductor, which then stores that energy in the form of a magnetic field. The inductor then charges the other plate of the capacitor and the process starts again, but with current now flowing in the opposite direction. The frequency at which this oscillation occurs is the resonant frequency, which is inversely proportional to root of LC. The voltage control oscillators can be constructed by using a variegated diode as a voltage control capacitor. As the reverse bias voltage across the variegated diode change, so does its capacitance, and therefore so does its frequency.
Now I will explain about this block diagram. First, the negative terminal of Vin is in series with Ri and connected to the negative part of the op-amp. A capacitor is placed on the feedback of the op-amp, and the programmable junction transistor PUT is connected in parallel with a capacitor, and the gate of the PUT is connected to the positive terminal of the variable DC voltage VP. And last, the output Vout will form as a sawtooth shape. And before we learn about this topic, we must know about PUT. PUT is a 4 layers semiconductor that is more used in electronic circuit, for example switching, relation, oscillator applications, and timing functions. It has 3 terminals, which are the anode, cathode, and gate. It will turn on and act as a forward bias to allow current to flow through if the anode voltage is higher than 0.7 volt, and it can be adjusted by varying the PUT gate voltage VP. When the anode voltage falls below 0.7 volt, the PUT turns off and the current cannot flow through.
Now, let us proceed to operation of the circuit. First, when the PUT is off and no current can flow through PUT, and the capacitor C charged up and the output is increasing positive going up ramp. As we can read the graph at the right side, there is no current initially. The capacitor makes it charge up to V peak. Secondly, when the output ramp reaches the maximum peak value, V peak, the PUT switch on and allow current flow through it. Thus, no current flow through capacitor causes the capacitor discharge rapidly by time. The capacitor discharge immediately in ideal situation. The output voltage VO falls back to minimum peak value VF. Now we read the first diagram at the right side. We can see that the graph decreased drastically to 0 after it reached V peak. This means that the current flow through the capacitor discharged rapidly. Lastly, since VO falls back VF, the PUT turns off and no current to allow to flow through the PUT. The capacitor starts to charge again to produce positive going up ramp's output. Let us read the second diagram at the right side. The graph has drawn recurringly. So in short, the operation of the VCO circuit is the capacitor charges up the current and the current flows through until V peak, then discharges rapidly and keeps repeating.
formula for VCO that we can calculate is the time takes a capacitor to charge from Vf to Vpeak is the period t of the sawtooth waveform. And the formula of t is RIC times Vpeak minus Vf divided by absolute Vin. And the unit of t is in second. To calculate the oscillation frequency, we know f equal to 1 divided by t. So we can get the formula which is absolute Vin divided by RIC times Vpeak minus Vf. The unit of frequency is in Hertz. Next, what is the application of oscillator? VCO are used in function generators, phase lock loops including frequency synthesizers used in communication equipment, and the production of electronic music to generate variable tones in synthesizers. Furthermore, the audio frequency VCOs are used in analog music synthesizers. For this, sweep range, linearity, and the distortion are often the most important specifications. In addition, they are also used in phase lock loops, frequency synthesizers, and also clock generator. And that's all from our group 2. Thank you for lending your ears.